All right, I believe this is question number 8. And here's some help for you regarding this question. The question reads, you have a large flashlight that takes 4 D-cell batteries. We can just say it's 4 batteries, 4 cell batteries. But this particular D-cell are those large batteries that you were using, some of you, in your current circuit building on Wednesday and Thursday. If the current in the flashlight is 2 amps, current, what is the resistance of the light bulb? And there is the thing that we're trying to find is resistance. And we have given you a hint here. A D-cell battery has 1.5 volts. Now, where to start? Because we just don't have one D-cell battery. We have 4 D-cell batteries. And just to give you a bit of a heads up as to what we're talking about here, if we were to draw this, like we said, that is representing one cell. And if we want to, that's one cell there with a negative terminal and a positive terminal. But we don't have just one cell, we actually have 4 cells. So what we got to do is we've got to add in 4 or 3 more cells for a total of 4 cells. Now I'm drawing this out to try to illustrate a point here and to draw your attention back to the stuff that we've been doing when we were building our circuits, and also the stuff that we were talking about when we were reviewing those measurements that you were making back with your circuits when we started looking at those different diagrams, circuit diagrams, back on Thursday. So here are our 4 D cells, and like we said, each D cell is worth 1.5 volts. Now, you may have actually discovered this just with this circuit building, is as you add more and more D cells in series, or more and more cells or batteries in series, you would notice that the voltage would get higher. So in one way you can think of is that when you have the 1.5 volt D cell battery, and you start adding more and more of these D cell batteries together in series, those voltages add up. Now, for some of you, you guys were using some of you were using 9 volt batteries, and you never had to add more D cells to your circuits. Now, the conversation we had on Thursday was through the measurements that you were making using your meters, we discovered that as we added loads or devices in series, we noticed that the voltages would add up. And we noticed that with light bulbs, with loads, and yes, it also applies to cells and batteries. So I guess the missing piece here, if you're having problems with this first part, is that if you have 4 D-cell batteries, each of those D-cells being worth 1.5 volts each, those voltages add up because they are connected in series. And that's what we have here. So this whole thing is actually is actually, let me just backtrack, 4 times 1.5. And that is going to equal 6 volts. And there it is. So this entire power source with these 4 D-cell batteries is 6 volts. Now that we've got that, we can go ahead and figure out what this equation was all about, or what this problem was all about, which was about finding resistance. And again, we go back to our good old triangle here and just take a look at Ohm's law. We're looking for resistance, so cover up resistance. There it is. So now the equation is going to read resistance equals voltage divided by current. Let's write that down. Resistance equals voltage divided by current. And now we know exactly what that voltage is, because we can say that we've got those 4 1.5 volt cells in series, and we also remember what the current is from up here, which is 2 amps. And we just do the math. 6 divided by 2, 3 ohms. Awesome. And that's your answer. Now, just to let you know, the next question you're going to come across, and this is for question, I believe, number 9, you are going to come across the circuit that looks like this, and it's going to refer to two arrangements of batteries. And based upon what we've just discussed here and what you know about having things placed in series versus in parallel, you should now be able to work that question out too. All right, so there it is. Good luck, and I hope that helps.